Now, when it comes to these parts, is the easiest way I can think of to give you guys a little scenario is two major things. The first thing is we're either going to be multiplying the entire equation by r, or we're going to be squaring both sides. Those are the two major strategies we're going to be using to convert one to the other, and vice versa. Okay, so for instance, let's look at this, right? So basically the question is we want to convert each to its other coordinates. So the first three we want to convert into x, y, and the other two we're going to convert into polar, right? Because it'll be the opposite directions. Meaning, since we're going to go from polar to rectangular, we're going to be using these to help ourselves out, right? So whenever we see r cosine theta, that automatically gives you x. Whenever you see r sine theta, that automatically gives you y itself. But we have a problem, right? This doesn't have anything like that. So that's what we got to figure out this way. So this is what I mean by, why don't we just multiply both sides by r? So if I multiply this by r and that by r, we get r squared is equal to 10r cosine theta, right? Now we know r squared is equal to the radical square root of x squared plus y squared. So we know r squared is x squared plus y squared, right? Just by knowing that. Just put that in there. So we know that substitution works already. Now notice this is exactly x, right? R cosine theta is, by definition, the x variable. So this is going to be 10x. That's it. Voila. We converted it. That's all. We're not going to do anything else by then when it comes to it. Okay. So let's try the next one. Okay. All right. So it's kind of funky. So why don't we try doing the same thing we did over here? Let's make it bigger. R squared, r equals or something like that. So why don't we just flip this around? So we'll have r is equal to sine theta minus 2, right? All I did was solve for r. Now notice we have the same scenario we have over here. So why don't we multiply both sides by r? So we have r squared. This is going to be r sine theta minus 2r, correct? And notice we have the exact same process. So this is x squared plus y squared is equal to, this is going to be y minus 2. Now remember, we want to get rid of everything. So in other words, your answer should be an x and y only, right? So no r should be, theta should be involved. But we do know what r is, right? R is equal to radical x squared plus y squared. So that's exactly what we do. Radical x squared plus y squared. So even though it looks kind of funky, don't worry. When it comes to your homework, you're going to see kind of funky. You can leave it just like that. All they did in your homework is simplify it, which you do not have to if you don't want to. Okay, things like that. All right, so let's try C. So C is actually very easy, believe it or not, because what's sine squared plus cosine squared? 1, isn't it? Right? That's a Pythagorean identity. Yeah, look at that. Square both sides, so r squared is equal to r. Oh, sorry, square both sides, Square both sides, Square both sides. So r squared we know is x squared plus y squared, and then 1 squared is just 1. So look at that. It's a circle. Okay. Right, so hopefully not too bad, right? So again, right, use the same strategies. These two we multiply by r. This one we squared both sides to get that portion. Okay. Now, you can actually do the same thing. If you want to multiply by r both sides, that's fine. You would have, equals radical x squared plus y squared, which again, if you really simplify down to it, you would get the exact same thing, believe it or not. Pretty interesting stuff. Okay. All right, so now we want to go backwards. Given x and y's, go to polar, which means, again, we're going to be using these to help ourselves out. Okay. So whenever you see an x and a y, we're just going to plug those in respectively. So these are actually much easier to deal with when it comes to it. Because, well, x is r cosine theta, and y is r sine theta. Right? I just literally substituted what x and y is respectively, and you can just simplify and make it easier. And again, if you want, you can leave it just like that. You can simplify that. You could divide by r to both sides, and you would get roughly this. And that's it. I'm perfectly fine if you left it just like that, or like that is fine, because there's not really much to do when it comes to these ones. Okay. So next one, so negative 2 times r sine theta times r cosine theta, because it's x and y equals 7. And we just simplify, right? So this is negative 2r squared cosine theta sine theta is equal to 7. And again, you can leave it just like that, it's fine. And then finally, this is a nice one, because if you just convert this, this is 3r squared cosine squared theta plus 3r squared sine squared theta is equal to 3. Now again, you can leave it just like that, but just for fun, I'm going to show you guys how you can simplify this to make it easier. Because if I factor out on this side a 3r squared, I get that. And then we know again, right, cosine squared plus sine squared equals 1. So this ends up being simplifying just strictly down to that. And if I go that even further, I get that. And there's a line. Pretty interesting stuff, huh? So that's 9.1, polar coordinates. Next section, we'll talk about how to graph in polar coordinates, a little bit more trickier.